Okay, students, very good evening. So this is actually the session which is planned towards your placement interview perspective. So according to the survey we have collected from your class coordinators, so majority of the students you have opted your area of interest as database management system. So that we have planned the first session on database management system. So then in future, maybe within next few days, we are going to have some technical session on data structures, operating systems, computer networks, and object-oriented programming, etc. Before we are just diving into the DBMS technical session, I wish to convey one thing. So this technical session is not only for any one of the company perspective. So you can have this session for attending any of the company's technical interview. So by attending this particular session, whatever the clarifications you are having, you can get clarified and use this particular technical session for attending any technical interviews. So whatever the technical subjects you have mentioned as your area of interest, you have studied in your previous semesters, maybe starting from second year. So for the whole semester, you have studied one subject, but before your interview, you are going to have the quick refresh. So definitely this particular session will not focus in very detail, but we are going to give some overview of the particular subject. So with this, a brief intro about the purpose of this particular technical session. So now in this particular present evening, we are going to start with database management system. In terms of interview perspective, what are the contents you have to go through? So for this particular technical session, with the help of one presentation, I'm going to share the overview of database management systems. But apart from this session, you form a peer group. Already a peer group is formed. By using the same peer group, you discuss with various concepts of the database management systems regarding your interview perspective. Daily, at least 20 to 30 minutes, you discuss in your peer group. This is my humble suggestion. If you are following, then definitely in the forthcoming technical interviews, definitely you will be able to exhibit your technical talents on DBMS in a effective manner. Okay. So with this, I'm just sharing my presentation. You just wait for a minute. So this is actually the presentation we have received from Wipro during one of the faculty training which is given by Wipro. So this is one of the very wonderful presentation to have a quick review on the concepts of relational database management system and SQL concepts. So that I am usually using this presentation regarding your placement perspective. So this is actually the 7 modules the Wipro has given to us. Introduction to RDBMS, entity relationship diagrams, schema refinement and normalization, Oracle SQL. Under this Oracle SQL, scoping and ordering of rows, DML statements, and finally group functions, a group by class, and join statements. So this is the 7 module under the relational database management system, which was suggested by Wipro. But during the placement timings, definitely we will be getting very short amount of time because we have to focus all the subjects. So it's very difficult to cover all the 7 modules in detail. But anyway, usually during the placements, I will be conducting 2 technical sessions for DBMS. So at least 60 minutes for one session. At least 60 minutes for one session. So today we will be starting the session by 4:45. So can you able to listen me for another 60 minutes I hope every one of you is able to listen for another 60 minutes. Suppose if some of the modules may not be covered within 60 minutes, in order to maintain the continuity, I'll be taking another 10 to 15 minutes. So this is for the day one plan, and the remaining topics I will be covering in day two, that is tomorrow. So out of this seven modules, the second module regarding the interview perspective, the construction of ER diagram, which may not be relevant, or most probably the interviewers, they are not asking the questions in ER diagrams. Out of this, uh, out of this seven modules, okay. So I'm going to focus the module number 1, 3, 4, 5, 6, 7. I'm skipping the second module, but anyway, this presentation is already available with you, so you can refer it. No issue. Okay, second module, if you are interested, you can refer it. Okay. So now the first module, introduction to RDBMS, because in any interview, the interviewers are checking the fundamental skills. The fundamental skills. So if you are covering this particular module, okay, so you will be able to understand the fundamentals of relational database management system. So the first, we are going to start with some basic definitions. Maybe some people, you are already started your preparation during your various technical interviews. Anyway, we'll be just giving some overview of DBMS by saying a fundamental definition. So you can just consider DBMS, which contains a set of programs. A DBMS contains a set of programs for creating and managing the data stored in database. So database management system is a software or a set of programs which is used to create and manage the data which is stored in database. So a database is actually a collection of interrelated data about a particular enterprise. To manage the database, we are going to use the software, that is DBMS. So you consider the keyword database management system, we are having the different decomposition of keywords: data, database, and database system. So you consider the data, which is a known fact that can be recorded and that have some implicit meaning. A meaningful fact is called data, and database is a collection of interrelated data about a particular enterprise. For example, student enterprise or employee enterprise or college or a project, whatever it may be. If you are having some collection of interrelated data, those collections of interrelated data are related data, which is called database. And what is a database system is the database plus the DBMS software. With the integration of database and DBMS software together forms a database system. So database system is actually a superset. In the database system superset, we are having database plus DBMS software. In database system, we can have data about a various enterprise. Okay, so this is the definition of database management system. So why we are going for database management system is to provide an environment which will efficiently provide access to data in the database. Efficient access, this is the first objective. So efficient access to the data in database, we are going for database management system, as well as to implement security, concurrency control, and recovery from crash. This is the three additional objective or additional goal of any database management system. So the primary objective is for efficient access to the data. The second objective is implementation of security, concurrent access, and then recovery from crash. So this is the primary and secondary goals of the database management system. So a general purpose facility, if you are taking to define the database, to construct the database, and to manipulate the database, we are going for database management system. So if interviewer is asking you, what are the various benefits of database approach? They are not asking fundamental definitions. Okay. So during the interview, the questions are towards the application perspective. So what are the benefits? Why we are going for database system? Or what is the reason which makes you to mention DBMS as your area of interest. So for that, you should understand the benefits of database approach. So you have to remember all these points. During the interview time, if some of the points are able to come into your mind, you can share. So easy access of data and redundancy. Redundancy, we all know the unnecessary repetition, which is called redundancy. So redundancy is reduced and data inconsistency is avoided and shared data is possible and some standards are enforced in your database system and security is applied and maintenance of integrity, data integrity and data independency is provided and abstract view of data is possible by means of database and multiple and simultaneous access of data. Multiple and simultaneous access of data. So these are all the various benefits of database approach. So this is the benefits. Now moving to the next slide. The history may not be needed for you, but anyway, you just have a quick glance. So how the database is evolved, starting from file system, then hierarchical database, then network database, then relational database, then object database, and object relational database. So this is the evaluation of database. But now we are in the era of big data or data science or data analytics. Even the utilization of conventional database is getting reduced because of introduction of big data. But anyway, the evolution of database starts from file system and the object relational database system is the mid of the 1990s. This is the version. But now in 2K, we have big data, data science, etc. So this is the history of database. So now you can just consider any database system. The users are interacting with database as well as the metadata. So we all know database, already we gave the definition. Data that gives information about other data. Okay. So simply, exactly, very good definition. So simply we can speak data about data, which is called metadata. Suppose you consider simple example. We are having an Oracle table. Okay. So about the table, we are having some data, like who is the author of the table and what is the date and time of the particular table creation, how many number of rows are there, how many number of columns are there. So these are all some of the examples of the metadata. So users can access the metadata and database with the help of some application software or query. But not normal user cannot access the metadata. Normal users can access only the database with the help of the application software or query. Once the users are giving some application software or query, the query is getting processed. Then the processing query can be given to a software to access the stored data. So then from database, that particular software get the data which can be given to the user. So this is a general flow of any database system. Only the database administrator or some sophisticated user can able to access the metadata. Not normal users can be able to access the metadata. So this is a very important thing. So this is actually how the users, okay, are giving a query. For example, the users are giving a query through any query language like SQL or any application programs like Java or Visual Basic .NET, whatever it may be. So whatever the queries the users are giving, okay, so the query can be given to the query processor. The processor is going to processing the query. You will be getting the compiled version of query, that is maybe the input to the database manager. So the compiled query which can be given to the database manager which will interact with the file manager to get the data from the physical database. Okay, so this is the user query is processed. So like that, the database schema, that how the database schema regarding for the metadata. Okay, so the database schema can be compiled using the DDL compiler. DDL, you know, data definition language. So this compiler which will compile the schema, which will give some database description. By means of the database description, it can interact with manager, which will fetch the metadata. So this is a simple architecture, a miniature of architecture. Maybe you have studied the overall architecture of database. Okay, but this is the miniature version how the user query is getting processed. Next, you consider any database system. There are three data models can be provided. One is the lower level is physical level. The middle level is conceptual level. The third level is external level. So in physical level, normally the users involved is DBA, database administrator. In conceptual level, DB designer, database designer. In external level, business users. We are the business users. Okay. Suppose if you are using the application in the end user level, you are the business user. So in the external level, the business users are involved. So this is the three levels form: physical, conceptual, and external level. Okay. So in this particular three levels, why we are having this three level is to provide the data abstraction. To provide, this is a very important keyword. Most of the interviewers, they are asking in interview, what do you mean by data abstraction? So data abstraction is nothing but hiding the complexity among the user by means of various levels. Suppose you consider end users, that is the business user, who are in the external level. They don't worry, they don't know about conceptual level, they don't know about physical level. They are the end user. They can view the database only. Okay. Like that, you consider the logical designer. Logical designer, they don't worry about the internal level. They are focusing on designing. But DBA, they are only focusing on the physical level, the data structures level. Okay. So in different level, we are hiding the complexity. We are hiding the complexity. So this is the purpose of this three different views. By means of these three different views, data abstraction can be provided. Okay. So what are the three kinds of abstraction? The physical level abstraction, logical or conceptual level abstraction. The third one is the external level abstraction. So this is the architecture or the abstraction levels. Now a simple example, an internal view, that is a physical view in the right hand side, and conceptual view and external view. So you consider the employee schema. In employee schema, we are all much familiar with our logical level because you are working in your lab. So when I want to design the employee table, so I'm having a different attributes like employee number, name, then father's name, and age of the employee, and salary, and in which department he is working. This is the conceptual view. So conceptual view will consist of all possible attributes. Now the same conceptual view is viewed by end users. So in end user is nothing but external level. In external level, it's not compulsory to view all the attributes. If they want to view only the personal information, the first table, employee number, name, father's name, age, that is sufficient. But in second table, they are focusing on salary. So in which department he is working, what is salary? So employee number, salary, and department number. So in both the table, you can see employee number is the common, that is the unique one. By means of the employee number only, we can able to identify the name of employee, father name, and age, etc. Okay. So this is the conceptual and business user level. We are all familiar. But what do you mean by the internal level or physical level is how the data are inside the system or inside the hard disk, how it can be stored, the physical level. Okay. So any table or any schema which can be viewed as a structure. Okay. You all know in C programming, the structure is nothing but maybe like abstract data type. Okay. Or a user defined data type which is having maybe the heterogeneous data types. The employee is the user defined data type which is having integer data, character data, float data, and one structure pointer, etc. Okay. So this is the three levels of abstraction. You be clear on this. This is the most important area. And you are having the different schemas also. Based on these three levels of abstraction, we are having external schema, conceptual schema, and internal schema. Okay, you just go through this. And again, the interviewers are touching on this data abstraction during the interview. If you are having any idea about the data independence, so data independence is nothing but change the schema at one level of database without need to change the schema at the next higher level. So very simple definition. Data independence is nothing but changing the schema at one level without changing the schema at next higher level. That is called IPO. I'm having level 0, level 1, level 2. If I want to change the level 0, I don't want to change the level 1 schema, that is called data independence. Okay, so we are having two types of data independence. One is logical data independence, and another one is the physical data independence. Logical data independence, and another one is the physical data independence. So if any logical data independence, you can see the definition, refers to the immunity of the external schema to changes in the conceptual schema. What is immunity in the sense, maybe like getting not affected. Okay, so the external schema is not affected due to changes in the conceptual schema. That is called logical data independence. For example, we are changing some logical schema designing, like adding the new record or adding the new field, okay, which is not affecting the external schema. That is called logical data independence. So the second type is physical data independence, which refers to the immunity of the conceptual schema to changes in the internal schema. For example, addition of index should not affect the existing one. Index in the sense, you know the purpose of index. The index is for fast access or quick access. Even if you are adding some new index, which will not affect the conceptual schema. That is called physical data independence. Okay. So you remember, you are making some changes in the lower level, which is not affecting the next higher level, which is not affecting the next higher level. This is called data independence, and it's not needed, history not needed. So with this overall a brief intro about DBMS, the term RDBMS actually coined by the person, Dr. E.F. Codd. Okay, E.F. Codd is actually the father of RDBMS. He coined the term relational database management system. Here, one of the additional condition can be provided by E.F. Codd. The additional condition is the DBMS should support the tabular structure for the data. Tabular structure actually it introduced in the RDBMS. Okay, so and also the relationship can be enforced among the tables. So this is the two additional conditions. Whatever the concepts you have studied already, all these concepts are applied in RDBMS, but in addition to that, two conditions. One condition is the system supports a tabular structure for the data with enforced relationship among the tables. So this is the definition of RDBMS. So now you consider the RDBMS is a system where the data can be accessed by the user with the use of relationship. That means in RDBMS, if you are having the collection of tables, all the tables are interrelated with each other. For example, by means of the primary key, foreign key, we can have the relationship between the tables. Okay, so this is the RDBMS, and some of the features of RDBMS is we can create the multiple tables in RDBMS. We can able to enter the data into them. Then every RDBMS is supporting the multiple, interactive query language. Interactive query language. So if you are taking Oracle as an RDBMS, what is the interactive query language Oracle is supporting? And the interactive query language for Oracle is SQL. So by means of the SQL interactive query language, retrieval of information is possible from more than one table. Retrieval of information from more than one table possible. That is one of the features of RDBMS. And which provides the catalog or dictionary, which itself consists of tables. That is called metadata. If you want to handle with metadata, we can have data dictionary, or it's called as DBMS catalog. Okay, so DBMS catalog or dictionary, which is available in any RDBMS to store the metadata or system table. This is some feature of RDBMS. So all these 12 rules are available in this presentation. So you just go through it. Okay, just go through it. But most probably the interviewers are not asking explicitly the COTS rule, but any one of the concepts they are asking, so you can explain. So you just go through this COTS principles or COTS rule. Okay. So out of this COTS rule, I have just listed out, not myself, the Wipro has listed out some of the important terms. Relation. Relation is nothing but a table. Okay. Whatever the table we are constructing, the table is also called relation. Every row in a table, which is called a tuple. This terminology, you just be thorough on this. Okay. So every row in the table, which is called a tuple. Every column is called attribute. Okay. So how many number of attributes in the table? Suppose a table consists of 5 columns. A table consists of 5 columns. Then there are 5 attributes, and the degree of table is 5. Degree of relation is 5. Okay. So degree is nothing but number of attributes. And what is the number of tuples? The number of rows, that is called cardinality. The cardinality is nothing but number of tuples. And primary key, we all know the unique identifier. The unique identifier is the primary key. And what do you mean by the domain? A domain is nothing but a pool, a collection of values or a set of values for a specific column. If employee number is one column, so how many employees are there? For all employees, the employee number is one domain. Like for example, in final year CSE 2022 batch, there are 226 students, they are eligible for placements. Okay. So all 226 students register number is one domain. But domain is nothing but a pool of values from which the specific attributes for the specific relation. That is called domain. And you consider the properties of the tables. Properties of the tables, you can just go through. There are no duplicate rows. According to the relational database, okay, so there are no 2 rows are same. 2 rows should not be same. That means all the values are similar. For example, employee number 100, employee name Arun, salary 10,000. Then same row 100, Arun 10,000. That is not possible in your table in relation. So there are no duplicate rows, and the tuples are unordered. Tuples are unordered. What do you mean by unordered? Suppose you can just consider employee number 100, 101, 102, 103. You should not maintain the order. Order is not necessary. Okay, top to bottom, the order is not necessary. Even if it is unordered, no issue. Okay, so like that, attributes also unordered, left to right. For example, first employee number, next salary, next father's name, next employee name. Like that, you can give attributes also unordered. And all attributes values are atomic. Atomic in the sense simple and indivisible values. For example, just a minute, I'll be just consider one of the student area of interest part. Just a minute, there is a mouse problem. Okay, student area of interest. Suppose I can take any one of the student. The area of interest they have mentioned as 2 area of interest. For example, one is the AI, another one is the DBMS. So one student is giving 2 area of interest, AI and DBMS. Okay. So can you say now this area of interest column is atomic? One student is having 2 area of interest. Can you say the area of interest column is atomic? Which is not atomic, because you can able to decompose these 2 values. One area of interest is AI and the second area of interest is DBMS. Okay. So this is not actually atomic one, which can be able to divisible. Okay. So according to the relational properties, all the attributes values are atomic. How we can change this? For one student, we have to put area of interest 1 and area of interest 2, or otherwise for one student, we have to create a 2 records. Okay. That is way the atomic property can be ensured. And then relational database do not allow repeating groups. Repeating groups is nothing but a concept of nested table, a table inside the table. So the repeating groups are not possible in your relational database. Okay, fine. Now next, coming to a very important point. In most of the technical interview, they are touching on these keys. Okay, so the keys, what do you mean by the key? The keys are used to uniquely identify the record in a table. Or a table, you are having a multiple records are there. How we are able to uniquely identify the record? For that, we are going to use the keys. Okay, so according to the relational model, theoretical relational model, we are having a different types, that is super key, candidate key. In candidate key, we are having 2 types. One is the primary key and alternate key, and the next one is the secondary key, that is foreign key or referential key. Okay, so this is the types of keys: super key, candidate key, and secondary key. In candidate key, there are 2 types. One is the primary key, another one is the alternate key. So here we are mainly focusing on referential integrity in RDBMS. Now there are 2 tables are there. You are able to see this. The first table is enrolled. The second table is student. Okay. So in this table, the SID may be the primary key. The SID may be the primary key. So you can just see, or maybe sorry, we can consider student is the primary table. Student is the primary table. So this here the SID is the primary key. He enrolled, that is one particular student is enrolled some courses like Carnatic or some other courses. Okay. So அந்த கோர்ஸ்ல அவங்க என்ன கிரேட் வாங்கியிருக்காங்க, this is called grade. Okay, like C grade, B grade or A grade. So now this SID is the primary key. By referring this SID of the student table, this SID is acting as the foreign key or referential key. Okay. So by means of this SID and this SID, the two tables are interconnected. The two tables are interconnected or interrelated. This is actually the concept of referential integrity. So now, so how the dependency is possible? The enrolled table is depending on the student table. The enrolled table is depending on the student table. Okay. Because always the child is depending on the parent. So in the child will be enrolled. So enrolled is depending on the parent student. Okay. So if you are having these kinds of a primary key and foreign key or parent child or master slave, one of the important property, practical application for the first insertion of records. Insertion. So remember first I for insertion. Insertion on the first to be done in the parent, then in the child. So insertion operation first to be done in the parent table, then in the child table. Then ademari deletion, it's a reverse. So deletion is happen first in the child, then in the parent. So these kinds of a practical explanation the interviewers are expecting. Okay. So insertion can be possible first in the primary table, next in the child table. The deletion is possible first in the child table, then in the primary table. So this is the concept of referential integrity. Okay. So this is about the points regarding the overview of DBMS. Okay. Now second module, as I have already told, the ER diagrams. I want to skip this ER diagram because in interview most of the panels the ER diagrams they are not touching upon. Okay. So I can skip this ER diagram, but if you want you can refer it in the slide. Okay. Even there are good interesting concepts are there in ER diagram. If you want you can refer. Okay. So I am directly moving to the third module of different types of normal forms and what is the problem with unnormalized data and some cleansing and ER diagram. Okay, these are all these some of the outcome of this particular module. Okay, we will just quickly diving into normalization. What is normalization? Okay, so if you are going for designing the relational database, so we should avoid anomalies and we should reduce the redundancy. We should reduce the redundancy. Okay, so what is normalization? Clearly, you have to say in the interview, designing the database without any anomalies, designing the database such that the redundancy is reduced. Redundancy is reduced. Okay. So this is the 2 points you have to say clearly during the interview panel. So how this can be achieved? How this can be achieved? Okay. So you can just consider the different types of normal forms according to the industry perspective. The normal forms are first normal form, second normal form, and third normal form, and boys for normal form. But theoretically, when you are studying, you have discussed 4NF, 5NF. But why the industry is stopping with BCNF is because the industries are using the very large tables, the real-time tables. For the real-time table, achieving up to third normal form is the biggest task. So they won't go with BCNF, they won't go with 4NF or 5NF. Okay. If they will achieve up to third normal form, the great success. Okay. So that maybe they have concluded the normal forms up to third normal form or BCNF. So why we are going for normal forms? To understand how complex our database is and to know in which state we are in. Our database is suffering with anomalies or our database is suffering with redundancies. Okay. What is the criticalness in the database, the criticality, okay, whether all the operations are performing smoothly, okay. So all those things are very important. We have to study. So for that, we are going for normal forms. Okay, first, redundancy. So we all know redundancy is unnecessary repetition of data. Or simply we people are saying that redundancy is nothing but duplication. Okay. So this is actually the main root cause for all the anomalies. So there are three types of anomalies. You are all familiar. Maybe for the previous interviews, if you start prepared, you are all aware of these anomalies: insert anomaly, update anomaly, and deletion anomaly. Okay. So due to this redundancy, the memory of the system is getting affected. The huge memory loss is possible. So the issues with redundancies are this is the root cause for all three types of anomalies and huge memory loss. So that we have to try to minimize the redundancy. Okay. So we are going to now understand the different types of anomalies, because in interview panel they're asking explain the insert anomaly with one real-time example. Even you can take this example. So how many columns are there? Name, father's name, address, which exam the student is applied, what are the subjects he is preparing for exam, and what is the mark. So there are two students, one is the Suresh, another one is the Kumar. They are writing, one is the OCP, Oracle Certified Professional, and another exam is OCA, that is Oracle Certified Associate. Consider this above example for the insert anomaly. Suppose if the Suresh initially he is having one record for the OCP exam. So now Suresh is appearing for some Microsoft certification. For example, Microsoft certification in some C programming or Python, whatever it may be. Now what happened? According to this particular schema, I want to introduce a new row for the Microsoft exam. And the Microsoft exam ko a new row na create pandren appadina, I have to repeat the father's name, I have to repeat the address. The personal information also is getting repeated. Am I right? Enter all the details such as name, father's name, address, repeat panano. For example, Suresh, Abhishek, Bangalore, Microsoft certified, and subject is Java, and not Java, maybe I can consider .NET. Okay, subject is .NET and mark is 40. Idhe mari Suresh is appearing for 10 exams abdina, what may be the size of table? Okay. So redundancy is very high, because for every record we have to repeat the personal details. Okay. So this is actually called the insert anomaly. So if you are going to insert some new record, we need to once again enter all the details unnecessarily. Unnecessarya nariya data nama repeat pandra maadhiri irukum. This is called the insert anomaly. Why this is called insert anomaly is, during the insertion some anomalies happen. So or insert பண்றப்போ நமக்கு சில issue வருது. That is redundancy வந்து increase ஆகுது. Okay, that is called insert anomaly. So like this second one, update anomaly. So you can see the table, two students appearing for OCP and OCA. Okay, so now if any one of student wants to change the address, for example Suresh is changing from Bangalore to Chennai. Now assume Suresh is appeared for 10 courses like OCP, Microsoft, Python, .NET, like that. Okay. If he wants to change the address, he is giving a request. If 10 courses he is doing now, so 10 times we have to update, right? In 10 records we update pannanum. So this is called the update anomalies. Then third one is called the delete anomaly. So during deletion we can face some issue. For example, Kumar, you can just consider Kumar. Okay, so Kumar is the person, he is the only person doing OCA, Oracle Certified Associate. Okay, now he has completed Oracle Certified Associate. Now what we will do, we try to delete the record. But if you are trying to delete the record, in addition to the Kumar's record, for OCA, which subject needs to prepare, that information also will be getting deleted. If you want to get the OCA, Oracle Certified Associate, you have to prepare the PSQL. That information also will be getting deleted. This is called deletion anomaly. So when you are going to delete some information, some other useful information also will be getting deleted. This is called deletion anomaly. Okay. So this is the three types of anomaly due to redundancy: insert anomaly, update anomaly, and deletion anomaly. Hope this is a very simple example. In the example nalla clear panel explain pannalam, but this is not mandatory. If you are having your own example, be clearly construct the table and explain the example. Okay, but online la vandu eppadi neenga paper pencil la use panna mudiyum enak theriyala, but you have to be nalla interactive explain pananum these three types of anomaly. Okay, fine. So now how these normal forms can be implemented? The first version of normal form is 1NF, that is the first normal form. So every one of you, you just remember the keywords of all normal forms. இப்போ உங்களை நான் வந்து மூணு normal form தான் பார்க்க சொல்றேன்ப்பா. 1NF, 2NF, 3NF. If you are interested, you can refer the textbook of DBMS, or you can refer any notes shared by your faculty members. You can prepare BCNF, 4NF, 5NF. But be strong in first three normal forms, 1NF, 2NF, 3NF, with some real-time example. So for this, the slide is very much useful to you. So you can consider first normal form. The definition is all the values in the relation is nothing but table. All the values in the table are atomic in nature. Atomic பத்தி already நான் சொல்லிட்டேன். இப்போ அதே example இங்க கொடுத்திருக்காங்க. You can see if all the values in the table are atomic, then we can say the table is in first normal form. The subject column of Suresh, which is having 4. One is SQL, PLSQL, and the fundamental 1 and fundamental 2, like that, 4 subjects. So this column is not in atomic. This column is not in atomic. Okay. So we have to overcome this subject column of the first record. Subject column of the first record. Okay. Okay, fine. You can see, and this is as per the rules of first normal form. Every subject column or all the columns should be atomic. So what I will do is, for one student Suresh, he is opting for 4 subjects for OCP. So you created 4 records. You can see this table. Whether this design is good or not, this design is not definitely good, because more redundancy are there. More redundancy for one student, for one student, repeating the father's name, repeating the address, repeating the exam, etc., etc. Okay. So, but even though there are redundancy, this table is supporting the first normal form. So that every one of you clear, if you are achieving the first normal form, it is not mandatory that the table is not suffering with redundancy. Even though table is with first normal form, the table may be suffering with redundancy. Okay. So this is about the first normal form. So you can moving to the next type of normal forms. Okay, we are introducing the concept of functional dependency. So you can just consider the functional dependency. Simply, I can just write one expression. The expression is how we can pronounce this expression. Y will depend on X, or X is determining Y. X is determining Y, or Y is depending on X. Okay. So or simply you can say X tends to Y. So here you can just consider the X is one set of attributes, Y is also one set of attributes. Even this may be a single column or multiple columns. Otherwise, Y is single column or multiple column. Okay. So we can say here which one is the determinant. The X is called the determinant. You can remember this keyword. X is called the determinant, DET, and Y is called DEP, that is a dependent. The Y is called dependent. So dependent is always depending on determinant. So X is determinant, Y is called dependent. Normally in the implication, the left hand side of the implication, which is called antecedent, the Y is called consequent. Okay. So always the antecedent are determinant, the consequent are dependent. Okay, X tends to Y. So by means of this functional dependency, we can just introduce the 2 types of dependency. One is the full dependency, another one is the partial dependency. Suppose normally when you consider this determinant, this determinant normally a primary key. So the meaning is the non-prime attribute is depending on the prime attribute. Let's see this simple table. There are 3 columns: name, exam, marks. So here I am having the composite primary key பா. Composite primary key இப்போ இந்த நேமுக்கு பதிலா நீங்க எக்ஸாக்ட்டா நீங்க ரெஜிஸ்டர் நம்பர் வச்சுக்கோங்க. அப்பதான் உங்களுக்கு வந்து அது கிளியரா புரியும். ஏன்னா நம்ம காலேஜ்லலாம் சேம் நேம் நிறைய பேருக்கு இருக்கும். அதனால வந்துட்டு இங்க நான் இந்த நேமுக்கு பதிலா ஐ கேன் கீப் ரெஜிஸ்டர் நம்பர் வச்சுக்கிறேன். இப்போ உங்களுக்கு அந்த கன்ஃபியூஷன் வராது. ஓகே, ஸோ நவ் திஸ் ரெஜிஸ்டர் நம்பர் மேபி எக்ஸாம், ரெஜிஸ்டர் நம்பர் எக்ஸாம். ஓகே, இப்போ நம்ம நேம்லேயே கூட வச்சுக்கலாம். பட் எனிவே நேம் வச்சாலுமே சேம். நீங்க என்ன கேள்வி கேட்பீங்க, சார் சேம் நேம் சேம் எக்ஸாம் எதுனா எப்படி சார் அதை பிரைமரிக்கே வைக்க முடியும்னு சொல்லிட்டு. ஸோ வி கேன் ஹேவ் 3 columns பா. ரெஜிஸ்டர் நம்பர், நேம், எக்ஸாம். ரெஜிஸ்டர் நம்பர், நேம் அண்ட் எக்ஸாம். ஓகே, ஸோ இது வந்து நம்ம 3 columns வச்சுக்கலாம். இப்போ ஐ கேன் சே இந்த மூணையும் சேர்த்து நான் ஒரு பிரைமரி கீயா வச்சேன்னு வச்சுக்கோங்களேன். திஸ் இஸ் கால்டு காம்போசிட் பிரைமரி கீ. இல்லை நம்ம ரொம்ப நம்மளுக்கு கொஞ்சம் காம்ப்ளெக்சிட்டியா இருந்துச்சுன்னா இதே எக்ஸாம்பிளே நீங்க வந்துட்டு ஜஸ்ட் மினிட் ஐ வில் erase all link. இதே எக்ஸாம்பிளே வச்சுக்கோங்க. ஃபர்ஸ்ட் சிம்பிளா நேம் அண்ட் எக்ஸாம் which is combinedly acted as a primary key. So இந்த மாதிரி ஒரு more than one column இருந்துச்சுன்னா which is called composite primary key. So இப்போ இது வந்து primary key, இது வந்து composite primary key. And which one is the non-prime? Which one is the non-prime? The mark is the non-prime. Okay, the mark is the non-prime. So I can have the functional dependency in the name and exam which combinedly determining the marks. இல்லைன்னா student mark is depending on name of the student in exam. இப்போ for example அருண் ரெண்டு ஸ்டூடெண்ட் இருக்காங்க, இல்லாட்டி அருண் பாலா அப்படின்னு ஸ்டூடெண்ட் இருக்காங்க. இப்போ அருணோட டிபிஎம்எஸ் சப்ஜெக்ட்ல எவ்வளவு மார்க், அருணோட ஏஐல எவ்வளவு மார்க் அப்படின்னு நான் பார்க்கணும். அப்படின்னா நேம் அண்ட் எக்ஸாம் is combinedly determining the marks. Non-prime attribute marks, the non-prime attribute marks is fully depending on the primary attribute. The non-prime attribute is fully depending on primary attribute. Okay, so this is called the full dependency. So because exam மட்டும் வச்சு என்னால மார்க் சொல்ல முடியுமாப்பா? இப்போ AI exam determining marks, but எந்த ஸ்டூடெண்ட்க்கு எவ்வளவு மார்க்னு எனக்கு தெரியாது. So that only name and exam which combinedly determining marks. So this is called full dependency. The next one partial dependency. இப்போ இதே கேஸ்ல பாருங்களேன், name, exam, marks and date of birth. Birth is only depending on name. So அப்போ marks வந்து இது ரெண்டையுமே டிபெண்ட் பண்ணி இருக்கு, அது வந்து full dependency. But date of birth வந்து only name மட்டும் தான் டிபெண்ட் பண்ணி இருக்கு, exam டிபெண்ட் பண்ணி இல்ல. So this is called partial dependency. Okay, so this is the two types of dependency, full dependency and partial dependency. So with this dependency I am giving the definition of second normal form. So any higher level normal form that should be in lower level normal form கண்டிப்பா இருக்கும். So 2NF it should be in first normal form, but all the attributes should have full dependency. That means all non-prime attributes is fully depending on the prime attribute. So all the attributes should have the full dependency. No partial dependency is allowed. இந்த கீவேர்ட்ஸ்லாம் நல்லா ஞாபகம் வச்சுக்கோங்க. இன்டர்வியூல நல்லா ஸ்ட்ராங்கா பேசுங்க இந்த மாதிரி, சரிங்களா? It should be in first normal form. All the attributes should have full dependency, sir. No partial dependency is allowed. For example, you can just share your screen or you write using some digital pen or typing in the notepad. You can explain. Okay. So this is about the second normal form. So now the third normal form. If for example in this particular case, okay, I'm having name, exam, marks, date of birth. So how I can this is actually available in the first normal form, but partial dependency இருக்கு. இப்போ இந்த டேபிள்ல நான் செகண்ட் நார்மல் ஃபார்மை மாத்தணும் அப்படின்னா I have to avoid this partial dependency. அப்ப நான் என்ன பண்ணணும் அப்படின்னா I am going to use the decomposition. Decomposition என்னப்பா நார்மலா? Decomposition என்ன? ஒரு டேபிளை வந்து ரெண்டா உடைக்கிறது. I am going to break the table into 2 or more tables. இப்போ இந்த டேபிள் எப்படிப்பா பிரேக் பண்ணலாம்? How I can break? So I can break, நான் ஷார்ட்டா ஃபர்ஸ்ட் கீவேர்ட் மட்டும் எழுதுறேன். நேம், எக்ஸாம், மார்க்ஸ். இது ஒரு டேபிளா வச்சுக்கலாமாப்பா? நேம், எக்ஸாம், மார்க்ஸ் இது ஒரு டேபிளா வச்சுட்டா எஸ். இப்ப செகண்ட் டேபிள் இது வந்து டேபிள் 1. இப்ப செகண்ட் டேபிள் நான் எப்படி வைக்கிறேன் அப்படின்னா நேம் அண்ட் டேட் ஆஃப் பர்த், நேம் அண்ட் டேட் ஆஃப் பர்த். அப்ப இந்த டேபிள்ல டிபெண்டன்சி எப்படி இருக்கும்? இதுமே ஃபுல் டிபெண்டன்சியா இருக்கும். பிகாஸ் டேட் ஆஃப் பர்த் இஸ் டிபெண்டிங் ஆன் நேம். ஸோ இந்த மாதிரி ஒரே இந்த டேபிள வந்துட்டு I can decompose into two tables. So in this particular moment, I wish to say one rule. What is the rule is, according to the relational database, always maintain a large number of smaller tables. இது மந்த்ரா, இது வந்து ஒரு ரிலேஷனல் டேட்டாபேஸோட ஒரு மந்த்ரா. லார்ஜ் நம்பர் ஆஃப் ஸ்மாலர் டேபிள்ஸ் அப்படின்னா என்னன்னா, டேபிளோட சைஸ் வந்து சின்னதா இருக்கணும், பட் we have to maintain large number of tables. இதே இது ஸ்மால் நம்பர் ஆஃப் லார்ஜர் டேபிளா இருந்துச்சுன்னா ரிடண்டன்சி அதிகமா இருக்கும். இப்போ இங்க பாருங்களேன், இந்த டேபிள் எனக்கு 4 காலம் இருக்கு. 4 காலம் இருந்ததுனால தான் எனக்கு ரிடண்டன்சி, அனாமலிஸ் அந்த ப்ராப்ளம் எல்லாம் இருக்கும். இப்போ இதை வந்து நான் 2 டேபிள டீகம்போஸ் பண்ணிட்டேன். ஒரு டேபிள்ல 3 காலம்ஸ் இருக்கு, ஒரு டேபிள்ல 2 காலம்ஸ் இருக்கு. ஸோ திஸ் இஸ் ஆக்சுவலி கால்டு large number of smaller tables. So if you are keeping large number of smaller table in your relational database, your design is pakka design, perfect design. Okay, so அந்த மாதிரி ஒரு டிசைன் பண்றவங்க தான் good relational database designer. Okay, so this is about full dependency and partial dependency. With the help of that, we can see the second normal form, and finally I'm going to conclude with the third normal form, transitive dependency. You can see this example. We all know transitive dependency na eppadi varum, x tends to y, y tends to z. So from this what you can infer? X tends to z. That on the transitive dependency we all know. Okay, so now in this particular case we can have one table: employee number, project name, number of hours and salary. If they can giving employee number and project name is the composite primary key. Employee number and project name, one employee may involved in different project. One employee may involved in different project. Okay, so employee number and project name is the composite primary key. Okay, fine. So now இப்போ இதை வந்துட்டு நான் என்ன எடுத்துக்கிறேன் அப்படின்னா எக்ஸ்ன்னு எடுத்துக்கிறேன்பா. இது ரெண்டே கம்பைன் பண்ணி எக்ஸ்ன்னு எடுத்துக்கிறேன். So this x is going to determine y. This x is going to determine y. Is it right or not? Can you accept? For employee project 1 la or 4 hours work பண்ணலாம், project 2 la 6 hours work பண்ணலாம், totally 10 hours. So can you say like this? Employee number, project name determine number of hours. So இதே இடத்துல பாத்தீங்கன்னா, இப்போ ஒரு எம்ப்ளாயி வந்து சில ஆர்கனைசேஷன்ல பாத்தீங்கன்னா பேஸ்ட் ஆன் நம்பர் ஆஃப் ஹவர்ஸ் அவங்களுக்கு சேலரி ஃபிக்ஸ் பண்ணுவாங்க. ஸோ இப்போ இதை வந்து நான் இசட்னு எடுத்துட்டா, ஐ கேன் சே நம்பர் ஆஃப் ஹவர்ஸ் டிட்டர்மின் சேலரி. நம்பர் ஆஃப் ஹவர்ஸ் டிட்டர்மின் சேலரி, தட் இஸ் y tends to z. ஸோ x tends to y, y tends to z. x tends to y, y tends to z. அப்போ can I say the transitive nature x tends to z? So இதுதான் வந்து transitive dependency. Okay, so according to the third normal form, first it should be in second normal form. Second normal form இருக்கணும், அது கண்டிப்பா first normal formல இருக்கும். Okay, this is the first criteria. And no other attribute should be transitive dependent on the primary key. Transitive dependency இருக்கக்கூடாதுப்பா, transitive dependency இருக்கக்கூடாது. அப்பனா வந்துட்டு we have to avoid this transitive dependency. இப்போ இந்த transitive dependency இருந்துச்சுன்னா கண்டிப்பா redundancy இருக்கும், anomalies இருக்கும், கண்டிப்பா anomalies இருக்கும். சரிங்களா? ஸோ இப்போ இதை நான் அவாய்ட் பண்ணணும்னாப்பா எப்படிப்பா இந்த transitive dependency நான் இது பண்ணலாம்? Again I am going for decomposition. How I can go for decomposition? Any guess? இந்த டேபிள இப்போ நான் வந்து எனக்கு இந்த transitive dependency இருக்கக்கூடாது, எப்படி நான் இதை டீகம்போஸ் பண்ணலாம்? எம்ப்ளாயி நம்பர், ப்ராஜெக்ட் நேம் அண்ட் நம்பர் ஆஃப் ஹவர்ஸ் ஒரு டேபிளா வச்சுக்கிறாங்க. அப்புறம் இன்னொன்று என்ன சொன்னீங்க? நம்பர் ஆஃப் ஹவர்ஸும் சேலரியும், நம்பர் ஆஃப் ஹவர்ஸும் சேலரியும். இப்போ இந்த மாதிரி நீங்க டீகம்போஸ் பண்ணீங்கன்னா நீங்க இங்க வந்துட்டு இதுதான் நீங்க பிரைமரி கீன்னு வச்சிருப்பீங்க. எம்ப்ளாயி நம்பரையும் ப்ராஜெக்ட் நேமையும் பிரைமரி கீயா வச்சிருப்பீங்க. பட் இங்க வந்து நீங்க எப்படிப்பா நீங்க ரெஃபரன்ஷியல் கீ கொண்டு வர முடியும்? டீகம்போஸ் பண்றப்ப கண்டிப்பா ரெஃபரன்ஷியல் கீ இருக்கணும். எப்படி இந்த ரெண்டு டேபிள் எப்படி ரிலேட் பண்ணுவீங்க? ரிலேட் பண்றது கஷ்டமாயிரும். ஸோ திஸ் டிசைன் இஸ் நாட் குட். இன்ஸ்டெட் ஆஃப் திஸ் நம்பர் ஆஃப் ஹவர்ஸ், எம்ப்ளாயி நம்பர் எங்க நான் வச்சுட்டேன்னு வச்சுக்கோங்களேன். இப்போ இந்த எம்ப்ளாயி நம்பரும் இந்த எம்ப்ளாயி நம்பரையும் வச்சு நான் ரிலேட் பண்ணிக்கலாம். அப்போ இந்த எம்ப்ளாயி நம்பர் எவ்வளவு ஹவர்ஸ் ஒர்க் பண்றாரோ அதை வச்சு இங்க நான் சேலரி நான் இன்சர்ட் பண்ணிக்கலாம். ஸோ திஸ் இஸ் த perfect design. முன்னாடி ஏசூர்யா சொன்ன மாதிரி பண்ணலாம், பட் ரெஃபரன்ஷியல் ப்ராப்பர்ட்டி என்னால கொண்டு வர முடியாது. அதனால the right design is, just a minute, I will clear the ink. So right design is employee number, project name and number of hours. இது ஒரு டேபிள். அண்ட் அடுத்த டேபிள்ல எம்ப்ளாயி நம்பர் அண்ட் சேலரி, இது ஒரு டேபிள். ஸோ இப்போ ஒரே டேபிளா இருந்ததை இந்த மாதிரி நான் ரெண்டா டீகம்போஸ் பண்ணிட்டேன் அப்படின்னா எனக்கு டிரான்சிட்டிவ் டிபெண்டன்சி போயிடும். இதுலவே பாத்தீங்கன்னா we are maintaining the large number of smaller table. ஒரு டேபிள் வைக்க வேண்டிய இடத்துல நான் 2 டேபிள் வைக்கிறேன். அதே மாதிரி 10 டேபிள் வைக்க வேண்டிய இடத்துல 20 டேபிள் வைக்கலாம். அப்படி வச்சீங்கன்னா உங்களோட டிசைன் நல்லா இருக்கும், அனாமலிஸ் இருக்காது, because of redundancy irukadu, anomalies irukadu. Okay, so this is about third normal form. Hope with this I am just completing my slide. The third normal form varaikum நம்ம வந்து stop பண்ணிக்கலாம். Then about denormalization etc we will continue in the next session. அதுக்கு ஒரு நீங்க இதுல நல்ல ஸ்ட்ராங்கா இருந்தீங்கன்னா போதும்பா, இதுல நல்ல ஸ்ட்ராங்கா இருந்தீங்கன்னா போதும், you can able to face any interview. Okay, so in this session for the past or 1 hour 15 minutes, okay, we have discussed the fundamentals of database management system and relational database design using normalization. Okay, thank you students for your patient listening.